Resistance. This video will cover the following learning objectives, and all of the content is included in the handout. Resistance of a circuit component shows its opposition to the current flowing through it. This means that the greater the resistance, the harder it is for current to flow through. The resistance is related to potential difference, so it's found using the equation resistance equals the potential difference divided by the current, and we can represent that using the symbols R for resistance, V for potential difference, and I for current. So R is equal to V over I. The resistance of the metal wire in a circuit changes as its properties change. As its length increases, the resistance increases, and we say that resistance is directly proportional to the resistor's length. As its cross-sectional area increases, the resistance decreases. We say that resistance is inversely proportional to the cross-sectional area. Series circuits. Components are connected end-to-end in one continuous loop. The current at every point in a series circuit is the same. So if I was to connect an ammeter at any point, it would read the same. The potential difference of the power supply is shared across each component according to their resistances. In other words, the total potential difference across the components in a series circuit is equal to the sum of the individual potential differences across each component. The combined resistance is the sum of the resistances of each component in series. Now let's look at that using an example. So we have two resistors of 4 ohms and 6 ohms which are connected in series. Our total resistance is equal to the resistance of our first resistor plus the resistance of our second resistor. So we can substitute our values into the equation. So RT equals 4 ohms plus 6 ohms, and that would equal 10 ohms. Let's look at our second example. Here we have 3 resistors connected in series of 2 ohms, 3 ohms, and 5 ohms. So our RT will be equal to 2 ohms plus 3 ohms plus 5 ohms. Therefore, our total resistance is 10 ohms. Parallel circuits. So components are connected to the power supply in separate branches that current can flow through independently. The current is shared between each branch. In other words, the sum of the currents in the separate branches is equal to the current through the source. So the current in the source is larger than the current in each branch. The sum of the currents entering a junction in a parallel circuit is equal to the sum of the currents that leave the junction. In other words, the current here is equal to the current here. The potential difference is the same across every branch in the circuit and is equal to the potential difference of the supply. The combined resistance of 2 resistors in parallel is less than the resistance of either resistor by itself. This is because the charge is split. Decreasing the charge to each component decreases its resistance. The combined resistance in parallel is given by 1 over the combined resistance equals 1 over resistance 1 plus 1 over resistance 2. One thing to note for this syllabus is that connecting lamps in parallel is advantageous because if one breaks, the current can still pass through to the rest. Let's take our first example. So 2 resistors of 6 ohms and 3 ohms are connected in parallel. Calculate the total. So our total resistance is equal, 1 over our total resistance, is equal to 1 over the resistance 1 plus 1 over resistance 2. We can substitute our values into this equation. So 1 over our total resistance is equal to 1 over 6 ohms plus 1 over 3 ohms. which is equal to 1 over 6 ohms plus 2 over 6 ohms. That is equal to 3 over 6 ohms. So 1 over our total resistance is equal to 3 over 6. Using this information, we can work out that our total resistance is therefore equal to 6 over 3, which is equal to 2 ohms. Let's take our second example. So we have two resistors of 8 ohms and 4 ohms, and they are connected in parallel. So we need to use our equation. 1 over the total resistance is equal to 1 over resistance 1 plus 1 over resistance 2. We can substitute in our values. So 1 over our total resistance will be equal to 1 over 8 plus 1 over 4 ohms. We can then simplify this, or you can put it directly into a calculator. To simplify this, we would get 1 over 8 plus 2 over 8, which will equal 3 over 8. 1 over our total resistance is equal to 3 over 8 ohms. Therefore, our resistance is equal to 8 divided by 3 ohms. When you put that into a calculator, you will get 2.67 ohms, and this is our